We're going to continue with the ideas of circumcenters and incenters. We are going to wind up in the coordinate plane. That shouldn't be a shock to you, because that's going to happen an awful lot. But we're going to start with this question. I just want you to, take a moment to read through it. A little hiccup there. That could be awkward during a podcast. But just take a minute, read through the problem, pause the podcast, and let's take a look at this problem. So which one is it? Do we want the circumcenter or the incenter? We want to be equidistant from the sides, because the roads are sides. I don't want to be equidistant from the intersections. I want to be equidistant from all three streets. So what I'm looking for here is a point that is on all three angle bisectors. So if I draw in my angle bisectors, so now I'm equidistant from all three streets. Which one is that? That is, of course, the incenter, not the circumcenter. If I wanted equidistant from all three intersections, that would be the circumcenter. There's a difference. But in this case, you want to be equidistant from all three streets. And then draw a sketch to show the location L. We just did it. Boom, right there. That's L. That's the location of my lamppost. So again, understanding the difference between a circumcenter and an incenter. Incenter is equidistant from the sides, formed by the angle bisectors. Circumcenter is equidistant from the vertices, or from the points, and it is formed by the perpendicular bisectors. 3 snack carts sell hot pretzels at points A, B, and E. What is the location of the pretzel distributor if it's equidistant from the 3 carts? Now, of course, we can't find a precise location. Come here. There we go. But if it's equidistant from the 3 points, what am I looking for? I must be looking for the circumcenter, the perpendicular, where the perpendicular bisectors intersect. So we have to construct our perpendicular bisectors. Again, I'm approximating. There's approximately my perpendicular bisectors. That would be my circumcenter. And I'm sure I did an absolutely horrible job of doing that, but you get the idea. Now, if we want to be precise with that, how would we do that? We use our construction tools to construct our perpendicular bisectors, which we learned how to do quite a long time ago. And that's fine. But I think the big deal here is to remember that this is the perpendicular bisectors. That's equidistant from the vertices, these distances now. And again, approximately, not too horrible. That's equidistant from the 3 vertices. How do we do this in the coordinate plane? Well, find the coordinates of the circumcenter of triangle ABC with vertices at A, 0, 3, B, 0, -1, and C is at 6, -1. So first let's plot our points. A is at 0, 3. B is at 0, -1. And C is at 6, -1. So there's my triangle. I'm going to draw my triangle real quick. There's my triangle. I need to find the perpendicular bisectors of all 3 sides. Now, fortunately for me, I've got a horizontal side and a vertical side here. And guess what? If I find where 2 of them intersect, I find where the 3rd one also intersects, because all 3 intersect at the same point. So I really only need to find 2 of the perpendicular bisectors. And lucky us, with horizontal and vertical lines, it's really easy to do perpendiculars. Because for the horizontal line here, the perpendicular is obviously going to be a vertical line. For the vertical line here, the perpendicular is obviously going to be a horizontal line. All we need to do is find the midpoint that it goes through, and we can graph this really, really quickly. So if this is 0, -1, and this is 6, -1, my midpoint very quickly, 0 plus 6 is 3. -1 plus 1, -1 divided by 2 is -1. So my midpoint here is at 3, -1. That's my midpoint. And my vertical line, my perpendicular bisector, is right there. Easy. My perpendicular bisector, my midpoint for this other side, AB, is obviously the x-coordinate is at 0. The y-coordinate right smack in the middle is +1. So my perpendicular bisector must be horizontal from that. Let's do red again. Right there. Where are those two lines intersecting? Very clearly at the point 3, 1. Which, by the way, is the midpoint of AC. Luckily enough for us. That is the circumcenter of that triangle. I don't need to write equations of lines here. I just need to find perpendicular bisectors and graph them because it was easy. Because we had the horizontal and vertical lines. That made my life a lot easier. Let's take another one. Find the circumcenter of the triangle with the given vertices. Let's just do the first one right now. So R is at -2, 5. So -2, 1, 2, 3, 4. There's R. S is at -6, 5. We have a nice horizontal line. And T is at -2, -1. Once again, we have the horizontal and the vertical sides. There's my triangle. Finding the circumcenter, going to be a piece of cake. I got to find the midpoint of each side. Well, honestly, finding the midpoints here is not terribly difficult. This side is clearly 4 units long. 1, 2, 3, 4. The midpoint is right there at -2, 3. And there is my perpendicular bisector. Here, from -2 to -6, my midpoint is halfway in between. That's at -4, 5. And there is my perpendicular bisector. And it becomes very quickly evident that my circumcenter is right there at -4, 3, where they intersect. Graph paper is obviously essential here. Drawing the picture, finding those midpoints, finding those lines. But with horizontal and vertical lines, life is very simple. You're going to see the same thing in example 3 here. We aren't trying to make your life horribly miserable. We are trying to get you to think algebraically, though, by using the coordinate plane. And that's important. That's what we've got for you today. More circumcenters and incenters. Make sure you've got those flashcards completed. We'll move on tomorrow. See you in class.